my name is Uta Priss. I'm presenting a paper at the Diagrams Conference on the topic of Semiotic-Conceptual analysis, or SEA, of Euler and Hasse diagrams. SEA is a mathematical framework for semiotics and provides a vocabulary, for example, for defining a sign, but also sign relations and types of signs. In this paper, SEA is applied to Venn and Euler diagrams. This slide shows an Euler diagram on the left and a Hasse diagram on the right. Both display the same information. The Hasse diagram has a node for each zone of the Euler diagram. So there are 4 nodes corresponding to the 4 zones, including the outer zone of the Euler diagram. The empty nodes in the Hasse diagram correspond to empty sets. Stapleton and others argue that Euler diagrams have maximum observational advantage. I would argue that Hasse diagrams display the same information. Most mathematical expressions don't provide any observations other than the expression itself, but there are some expressions where more can be observed. From the expression A subset B subset C, one can see that not only A is subset B, B is subset C, but also A is subset C. This meta-level Hasse diagram shows the difference between A subset B and B subset C, which is the empty node in the middle of the diagram, and the transitive relationship A subset B subset C. So these are questions which are of interest to semiotic-conceptual analysis. On the one hand, it seems that people find Venn and Euler diagrams quite iconic because the way how circles intersect and include each other may be similar to how sets do that. But one can also argue that Hasse diagrams are, from an algebraic viewpoint, much closer to how sets interact, and they are much more expressive. On the other hand, they are less intuitive to read.